Welcome to the Trident Analyst tutorial on auto sign detection. Using the reflectivity measurements from the laser scanner, this module automatically detects the position and measurement of the signs within a video sequence. When combined with the sign recognition functionality, the appropriate sign code based on a predefined database will also be assigned. Before you can run auto sign detection, you must have a point layer ready. I have created a layer called Sign Detect. This is the data model for this layer. The fields you should have are retroreflectivity, width, height, sign code, confidence level for the sign code, minimum ground elevation, and the confidence level for the minimum ground elevation. And this is the layer form for my layer. To begin detecting signs from laser data, launch the Auto Sign Detection module. From the Tools menu, select Extension Module Manager and click on the Load checkbox for auto sign detection. Click the Add button and select the layer files you would like to work with. You can select more than one file. I have loaded a laser file from my right scanner. Next, set the filter options. The sensitivity is the sensitivity level of the sign panel reflection. By default, all points having a reflectivity level higher than 0.68 will be considered. The minimum elevation is with respect to the ground. In this case, I want the software to detect signs that are at least 30 centimeters above the ground. The min distance sign to sign is the threshold in meters used to separate the point clouds of signs. So if the signs are within 50 centimeters of each other, I would like the software to treat them as one sign. The max lateral distance is the distance covered from the laser scanner. I would like the software to detect signs that are 20 meters to the right and left of the laser scanner. The min hit count is the minimum number of laser points to be considered a sign. In my example, the software will reject objects that have less than 20 laser points. The min and max height is the height that the objects must be within to be considered a sign. And the min and max width is the width that the objects must be within to be considered a sign. Finally, if you would like to limit the detection of signs to a specific section of the run, check the Use GPS time limits and enter a start and end point. If you leave it unchecked, the detection will be done for the entire laser file listed in the box. Next, set the output settings. Select from the drop-down menu the sign layer you would like to save the generated data to. If you don't have a layer, select Auto Create a Layer and the software will automatically create a layer with all the generated data for you. Then, select the name of the field you would like to save the data to. If you have existing sign locations and wish to perform change detection based on positional analysis, then you can have the software only add new items to the layer by checking the box next to Add New Items Only. The software will search for only new signs within the radius specified by the search buffer, which is 1 meter in this case. For new inventories, you would leave this box unchecked. Click Process to start the detection of road signs. If you are processing more than one file, each LAS file will be processed separately. When finished, the message log will indicate the number of signs detected. In this case, the software detected 119 signs. To review the signs that were extracted, open the 3D map. The red points are the signs that were detected. You can also perform the QA/QC process for the detected results. Scroll to a sign, select the Identity tool from the 2D Analysis panel, then zoom in on the sign and click on the red point. The layer form will appear with all the fields populated for the sign. Check to see if everything is correct. Scroll to the next sign and verify the results. If you get a form with an incorrect sign code like this one, then select the code field and change it by selecting the correct sign from the drop-down menu or use the sign recognition functionality. Note that the sign recognition functionality was automatically run during the detection process, but you can utilize it again during the QA/QC process to correct an error. Select the Perform Road Sign Recognitions tool from the 2D Analysis panel, open the sign library, and then click and drag the box across the sign. Based on pixel matching, the software will display a list of possible matches in the sign library. The top row contains the best matches. Select the correct sign and the software will replace the existing code with the correct code. There is also the option to filter the sign results by colors and shapes. Click Apply to save the changes and then OK to close the layer form. A more efficient way to perform this QA/QC process is using the Asset Tickmark function. Click on the Asset Tickmarks button from the Playback toolbar. Then select the sign detection layer. The layer form will appear for the first detected sign. Verify that the information is correct. Then, click Next Mark to jump to the next detected sign. Continue the process until you've verified the results for all the detected signs. That's it for this tutorial on auto sign detection. Thanks for watching.